Hello, everyone, and welcome to the Azure Community Conference 2020. My name is Alex Thissen, cloud architect at a company called Xspirit in the Netherlands, and I will be taking you on a one-hour journey to discover Dapper and its capabilities to build distributed .NET Core applications. We have a lot of things to cover, so let's move on pretty quickly. We want to build a single application that is distributed in nature, and it's going to show a leaderboard in a web browser with the top 10 people that are mentioned in regards to the hashtag Microsoft. So this is the end result. This application will be receiving all these mentions, and it will update automatically. So there's a lot of moving parts here that will be covered in this session, and we will build that within the time span of an hour. So first of all, there's the Twitter that sends out all these Twitter messages. We'll look at a stream of everything that has the hashtag Microsoft in it, and build a monitor application that will subscribe to the filtered stream and find out all the messages that Twitter exposes with hashtag Microsoft. We want to publish that to something else that will take care of who is the most mentioned user. And it will provide an API that will be called from the JavaScript and HTML front end. And it will store the results of the top 10 in a state store. Now, because we want to have this like a really distributed applications, we don't want to make calls from the Twitter monitor directly. Instead, we will use a bus structure and use Azure Service Bus instead. So our idea is to push the messages from the Twitter monitor onto the service bus, picked up by the most mentioned handler, which will store things and push out any changes that will be made in the top 10 for a particular hashtag out to the user front end. So it will push the notification there, and the application itself can call the API to update its list. Now, before we get started, let's spend some time looking at the differences between service meshes, when you have a distributed application running in a mesh, and the distributed application runtime, that is Dapper. Now, if you have some kind of orchestrator for your services and you use a mesh to help you facilitate discovery and other things, it's mostly infrastructure-centric. It's targeted at operators, and it takes away most of your networking concerns. Layer 7 routing, the mutual TLS authentication between services, and also providing some cross-cutting concerns such as telemetry, metrics, and tracing. Now, there's quite a number of meshes out there. The most famous ones or popular ones are Istio, Consul, and Linkerd. And you can use them and they will serve you well. But they don't provide you a programming model. So it won't be possible for you to interact with the mesh itself. There's a different approach that Dapper takes. It is more focused on the programmers. And it provides you with a set of building blocks, capabilities that will be provided from the runtime to your services and your application as a whole. So the distributed composition of everything. That way you can get new functionality in your application without having to take care of everything. Now, there is some overlap with what service meshes provide, especially in terms of telemetry and metrics and tracing. And you can combine them if you want to, but you will have to choose which side will take care of the cross-cutting concerns. Dapper itself is written in the Go language, but that doesn't mean that you need to write your applications in Go. You can use any of the supported languages and frameworks. It might be C++, Python, Java, or Go itself. And in this session, obviously, we'll be looking at .NET Core to help us build applications leveraging all the capabilities of Dapper. Dapper provides building blocks, which I like to think of as two sides. It's capabilities that you will always get, for example, service-to-service invocation, one service calling another, and there's the actor programming model. And additionally, there's a components part where you can add additional components to your application, giving you some type of feature, such as the ability to publish on a pub/sub messaging pattern, to do state store and tracing, or key management and secret stores. So there's quite a number of things that you can leverage. You will run your Dapper application consisting of all these moving parts on any of the major cloud providers: Azure, AWS, Google Cloud Provider, and maybe even Alibaba Clouds, anywhere where you can run your a container cluster. You can also run that on premises. You can use Service Fabric for it. So there's abundance of choice if you want to host your Dapper application. Now, the components themselves can be hosted on any of the other places where you are running your application. So you could, for example, run your Dapper application on Azure, while some of your components might be running in AWS or Google Clouds. There's a nice mixture possible wherever you are running your components versus where you are running Dapper itself. Dapper uses a sidecar architecture, and the sidecars are used to add some functionality to your application without being built into your application. There's already a number of places where that's being used, for example, for health checks or logging and telemetry, where that is outside of your application, but it's attached as a sidecar to your application. So imagine that we have an application built in .NET Core. It anticipates and facilitates the use of a sidecar. Dapper provides the sidecar, and once these two are connected together, your application will get additional capabilities provided by Dapper. It's non-invasive, so it's not really part of the logic and binaries of your application, but runtime, they are connected together. And they're communicating back and forth through APIs. So there's a loosely coupled, although albeit network-related connectivity between the two. Let's have a look at that would run in a Kubernetes cluster, because that's mostly the production scenario that you'll be using. If you install Dapper into a Kubernetes cluster, you will probably create a separate namespace for all system-related pods that will be made. One of the pods is the sidecar injector that takes care of injecting the sidecars into your application pods. There's one for placement of actors, if you're using the programming model for actors. There's a Sentry for certificate authority dealing with mutual TLS. And there's a component management operator that makes sure that if components are registered, that they're actually provided to you and connected to your application through the sidecars. Your application itself will most likely be running in a separate namespace. And whenever your application is being started, a container image will be used to create an instance of a running container. But because there will be special annotations that you choose to use for the manifest of your deployment, Dapper knows with the sidecar injector that it should add a sidecar into your pod that is running. And it does so for every part of your application that is annotated with the special markers that say, I would like to use a Dapper sidecar. Now, once these are in place, the work is done, and the sidecars, they know how to reach each other through MDNS and do that in a secure way with MTLS. And they will take care of all the communication. So the various parts and services of your application don't need to know about each other, and they will be able to find and discover each other by the sidecars. Now, the sidecars, they will use the components, and there's quite a bit of components that we can use. Let's have a look at those. So, for example, the Twitter monitor, let's take that as the example. We'll have a whole slew of building blocks, but the application code that is in there Your application code will be using the Dapr API to use the building blocks that are available. It will call into these APIs at a well-known endpoint, and these are versioned and correspond to each of these various building blocks that are out there. There's actually two different endpoints, one for gRPC and one for HTTP. And depending on which protocol you want to use, you would use either one of them. And gRPC is used by default. If you look at each of the components, so there's the capabilities, service-to-service invocation, and the actor programming model. The components are based on a set of abstractions. They take the capabilities for example, publish and subscribe, and abstract away all the internal details. And it's up to you to choose a specific implementation that will provide the components functionality. For publish and subscribe, for example, you can choose between Azure Service Bus or Event Hubs. There's Nets, there's a Google Cloud Provider pops up, Hazelcast, and so on. The more and more of these are coming, and they're provided by community efforts, people contributing and creating new components based off of their favorite components. For state management, for distributed tracing, and even for secret management, there's all these choices that you can make to pick the particular implementation of your components. The ones that you want to use are declared into text-based artifacts, and they are not stored as part of your application. This means that you can change the actual implementation of your components without having to rebuild your application. You just need to redeploy the definitions that you made, and because there's this abstraction between what your code knows and uses, you can switch out the implementation on the back end just by changing the declarative artifacts. So think of these as YAML files that describe which components you are going to use. If you look at the Dapper and how things are declared, there's a couple of components. This is how components are defined. You will have this YAML file specifying that kind of components, and you will use the meta name for the name of your component. And this is what you will refer to in your code or in your configuration. In the spec section, you describe the actual type that you will be using. So this is where you choose the actual implementation. And the metadata is a name value pairs that describes the particular details and properties of your components. And these might vary from one to the other. Then you have a single configuration file in your Dapper application. The configuration file at the moment has a single thing that you can define. It's the sampling rate for the tracing. In this case, it's 1% as the rate, indicating that 1% of all traces of all events will be sampled and put through the tracing logger. And then finally, you also have the annotations in your deployment manifest for Kubernetes. You see that the definition is that Dapper uses is very similar to the one that Kubernetes has. Inside the definition of your services, you will annotate and say that you want to use Dapper. The annotations are dapper.io, and you will specify a unique ID for your application, the port that it is exposed on, and the configuration that you want to use, which could be the one that we saw earlier, and whether your the sidecar is enabled, yes or no. Now, to get up and running, because if you want to use this, you need a couple of things. First of all, for local development, it's very nice to have Docker desktop installed. It will give you the Docker tooling and Docker Compose that allows you to run your application locally. You can even use the local Kubernetes cluster that you can run with it. It's kind of like a mini kube implementation. And next, you will install the Dapper command line interface to allow you to interact with Dapper, initializing it, starting, stopping instances, and also to deploy it to your Kubernetes cluster. Finally, if you have the command line interface installed, you need to take one final step, and that's initializing the Dapper runtime into your installation. That would be the Docker desktop for development purposes. But if you want to run in production, you will most likely deploy Dapper from the command line interface. But even better would be to use Helm charts to help you get everything installed with all the special pods that we saw earlier and operators that run in it. Now, if you are going to use Dapper on your local development machine, which is totally supported, you will find that it uses a special process, dapprd.exe, to spin up the sidecars. And they can run individually. You don't even need to use Docker for that. If you want to do that, you will do that from the root of your application directory. And this is what we will be looking at in a moment as well. You see that there's a Twitter monitor application. It has the regular .NET Core artifacts, but it also has this special folder with components. And if you want to run your application using Dapper as a sidecar, you will use the Dapper run command, specify a unique ID for your application, the port that it is expecting that your application will be exposed on, so they can start talking to each other, and finally, a path to the components folder. And the path to the components folder will be used when your application is talking to the sidecar. The sidecar will inspect this components path and find all the YAML files that are in there and inspect them for definitions of components that we saw earlier. And each of these components will be made available from the sidecar to your application code. So there's a port 5000 that's expected on your side of your application. So the sidecar can see when your application is up and running. It will try to reach that endpoint. And once it's found your application, it will expose its own two endpoints, the gRPC and the HTTPS endpoint. So your application can start calling the sidecar to leverage the functionality of the components and to call into other parts of your application. As a .NET Core developer, obviously, you want to have all the benefits and the programming that you know and love in .NET Core. Well, ASP.NET Core is most likely what you will be using, since your application needs to expose some endpoints. That is, allows the sidecar to talk to you. So you have all the builder extensions that you would expect. You will get distributed tracing for free. You don't have to do anything for that. You will get some state management with the binding for the state model. For publish and subscribe, you'll get some middleware and registration of the subscribers that are subscribed to it. You will get an actor programming model with timers and reminders, some configuration for secrets that you can use, and you'll have a Dapper client that allows you to do the service-to-service invocation and make it easier to use any of the components as well. Now let's go back to the agenda for today. This is what we would like to build. So there's quite a number of moving parts here. Let's get started with the bottom part. And the bottom part, we need to attach to something in Twitter. Now, the Dapper allows you to, because it's an event-driven runtime, it allows you to do input and output binding to various resources. And the resources can come from any of the cloud providers, or there will be other bindings as well. And what you do is similar to the components that we saw earlier. You specify the type of binding that you have, metadata that allows you to indicate the particular properties for that binding, and then Dapper, the sidecar, will take care of the rest. So in our case, we'll get a connection to Twitter, and whenever a Twitter message arrived, we get a chance to react to it. Reacting to it means that the sidecar, when it receives, in this case, a Twitter message, it will call a endpoint on our side, and it's related to the name of the component. We had a tweets component, and Dapper sidecar expects that you expose an endpoint that's called /tweets, because that corresponds to the name of your component. And when it calls that, in this case, we're creating an endpoint that calls whenever the post is made to tweets, it will call this method handle Twitter messages. And then you get a pretty low-level view of the incoming message that the sidecar is calling into with an HTTP post message. Another way of doing it is that you create a controller method in one of your controllers where you can do binding. So in this case, you can have an HTTP post as an attribute, specify the name of your method, and then use this object model tweet that will deserialize whatever is the payload of your method. So it's kind of an ideal way to not have to work with the HTTP context and deserialize things yourself. You will do model binding in your handler methods. And this will be automatically wired up because this will also expose an endpoint /tweets. Now, time to see that in action. So what we'll be doing is we will be looking at the Twitter monitor components and hook it up with a sidecar to Twitter. And we'll do this input binding as the first step in building the entire application. So let's get started and dig into some code. I'll pause this for a moment. That's the application running. And we'll start looking at the Twitter monitor implementation. It has a program CS file that is pretty boilerplate. It does a startup class for building up the web host. And if we look into the startup class, you can see that there's nothing much there. It has the usual configuration that's being made available. It has some configure services where this is the most important one to remember for later on, add Dapper client, exposing an object Dapper client. And then finally, in our configure, we will start using this endpoint /tweets, just like we saw in the slides. And handle Twitter message gives us this HTTP context that we can use to deserialize the content of the post message in the body ourselves into this tweet. And the tweet itself is this structure that has all the details of the Twitter message. And we'll be looking at the entities, and the entities again contain this user mention that is available. So there's this user mentions, and user mentions will be used where we will pick the user screen name and regular name so we can know who was actually mentioned inside of a tweet. So that's what we're aiming to find out. Now this is everything we need to get started. You will need some NuGet packages. As you can see, there's a NuGet package for Dapper ASP.NET Core. I've used the latest version that is usable from the 1.0 release candidate. And this is enough to get us started. If we go to a command prompt, I'm in the root of the application directory for the Twitter monitor. And what I can do here is I can start the application from the Dapper CLI. I will do a Dapper run, meaning that it will fire up a sidecar, and it will try to attach it to port 5000 and to this application that we will start up with our regular .NET run. The components folder is already there as well. And this is much like in the slides. We have this input binding where we have this tweets component, referring also to the endpoint that we've exposed, and it's of type bindings Twitter. And here are all the special secrets that we need, and the query that we're using, which is #Microsoft. So that will be our filtered stream. Now, if we run this, we should see that there's a lot of yellow starting our application. And let's go back a bit. It starts discovering everything that is and doing all this logging for the Dapper sidecar. That's in yellow. You will see that there's components being loaded, like the tweets. This is our Twitter binding. And it will start up the first part, and then it will start waiting waiting until we find something on port 5000. Now, our application is starting up in the regular way. So this is our .NET Core application booting. And as you can see, it exposes its endpoint at 5000, which is immediately picked up by the Dapr sidecar saying, okay, I've discovered this application, so let's move on and let's get everything bootstrapped. Now, after that, our application will start receiving those Twitter stream messages. And already we see that one has entered the logging because we're telling, okay, we found this tweet from @.NETBot in this particular, mentioned in a hashtag Microsoft Twitter message. And this will keep running, and it will it will receive all these messages, and we will use the fact that there's an incoming message to do something with it in our distributed application. So this is all good. I've stopped it, and you see that the sidecar is also stopping, and our application has exited as well as the sidecar. So we're down to running nothing at this point. Okay, now next thing. Our application code needs to call into sidecars to do something. It will have its own application logic, but as soon as it wants to reach outside of itself and call other services also running on the Dapper, or maybe use a PubSub component, it will do that through the use of the sidecar. Now, we already looked at the packages that were used. So you can use .NET Core, ASP.NET Core if you want to use it from ASP.NET, and there's also actors if you want to use it. So those are the main. But for the Dapper client, there's this special package, Dapper client, that is automatically included from ASP.NET Core that you can use to make it easier to call the sidecar. Now, again, make this any .NET Core application. The Dapper client is a strong typed object proxy to your sidecar. And it has all these convenience methods. So you don't have to build these HTTP calls yourself, figuring out what the specific endpoint is, because they're much more complicated than just this starting point. And also you don't need to take care of all the verbs like put and post and other things, and serializing your payload into it. You will use the NuGet packages. Dapper client, as I said, is the one that you will use for this, and it will give you this perception of the Dapper sidecar living in your code. And to get that all in place, we already saw the add Dapper client. You can do more configuration there and specify all these various options. But once you've done this add Dapper client, you can resolve the object, the strong typed proxy, into your code whenever you need it. And there's the regular ways. You can use a constructor injection where you will have the Dapper client object injected into your object, a controller in this case, or you can use a per method injection with the from services attribute that indicates that this particular object will be injected just when this method is being called. And this can be very convenient if you have a lot of controller methods, for example, and not all of them are using the Dapper clients, because in the case of constructor injection, it will be injected on each and every creation of your controller, and it will be used for every incoming HTTP method. Now, on the right-hand side, you can see that there's quite a number of methods that you might now be able to correlate to the various components, like state store and publishing of events for PubSub. Talking about PubSub, if you want to use publish and subscribe messaging patterns, most likely you want to use a message bus or an event bus. And because that's the nature of Dapper, it abstracts away the implementation, and you get to choose that. Whether it's Nets, RabbitMQ, Azure Service Bus, or Redis, it's up to you to choose the specific components, but you don't need to specify that or know that inside of your code. So your application that is the publisher will use the sidecar, and only the sidecar knows about the details when it needs to publish something. You will just call the sidecar, say publish event async, and that will take care of publishing something on the topic of your choosing. On the other side, we have subscribers that also use the sidecar. They don't need to because they could be picking up the messages from the event bus or the message bus by themselves. But with the Dapper sidecar, you get the same abstraction that your subscriber doesn't need to know what the particular implementation details of your message bus are. And the sidecar will do that. Once a message arrives, it will get that from the queue or the topic and call a well-known endpoint in your subscriber code. There might be more than one, so you can actually have single publisher, 0 or more subscribers, and all of these will receive the messages that will published on the other end. The way that the messages are transferring the data that the publisher wants to publish is by using a Cloud Events envelope. It has the Cloud Events 1.0 specification, and inside of it is the actual payload inside of the section that is called data. That's what it's actually all about. The rest of it is just for wrapping the message with a well-known standard, and the subject is the W3C tracing variant, so we can do distributed tracing across all of our services. To do the publish and subscribe, for testing purposes, you might use the Dapper CLI, and in the black box, you'll see that you can do Dapper publish and specify the topic. The particular pops up component, because you might have multiple buses there, and the data that you want to send. And in code, you could do it with the publish event async, which is listed here, where you specify the type of object that you want to have serialized. You specify the component name, the topic, and then your data. On the subscription side, you need to make a couple of changes to support the incoming messages on a topic and add a subscription there. So you will create a, use a bit of middleware that takes care of unwrapping the data from the Cloud Events envelope. And you will expose an endpoint that has all the subscription that you would like to have from your subscriber. And this is used by the Dapper sidecar to call into your application, ask for a special endpoint /Dapper/subscribe, and that should list in JSON format the subscriptions that you would like to have. And it will take care of actually creating them. Now, once these are there, the way that the incoming messages on the bus will be given to you in your application code is much the same as we saw earlier with the input bindings. So you will expose endpoints where you specify that the tweet topic has a particular method that will be called, and it will use that. Or you can annotate your controller methods with this attribute that says this is the component and this is the topic, and then it will use this method handle to do again binding and give you the data inside of the Cloud Events envelope deserialized into this object reference. Now, the nice thing about this is that the route and the topic are actually split. So that doesn't need to be the same one, and you can choose which way you're going. Now, finally, before we get into the next demo, let's have a quick look at the state storage. The .NET Core is again using the sidecar through the well-known URLs. This is where you can see that there's more involved than just the v10/state. You need to specify the store name to do a post and store something, and to get something or remove data from the state store, you will have the key also included into the endpoint. Now, here you have, again, choices of the actual implementation of the sidecar component that you want to use for state storage. So it can be anything from Cassandra, Redis Cache, Cosmos DB, or some of the other ones that are there. Just specify whatever you need, and the sidecar will take care of everything. There's a lot of things you can do with the options on how state is stored for consistency or resiliency, but that is up to you to influence that if you want to, or just leave it at the defaults. Important to remember is that the name of the component is also the name of the store, and that is the small link that you will be using and need to know inside of your code to refer to this particular state store component. Again, it's deeply connected into the .NET programming model from the Dapr.NET SDK, giving you these attributes like from state and your store name, where you can have this state entry generic that gives you a deserialized storage into an object reference for tweet. And with the Dapper client, you can, if you inject that into your method, you can use that in a similar way to start connecting to it. Now, let's build the next part of our application. We saw how our incoming messages were being handled, and now we'll look at what it takes to push that out into the Azure Service Bus, receive it on the other end in this component that is taking care of finding the most mentioned users in the #Microsoft Twitter messages. We'll switch to Visual Studio again. We were already up and running quite a bit. We were looking at this first part of deserializing and then logging some information that we saw that there were incoming tweet messages that we saw earlier. Now, the next thing that we'll be doing is publishing those messages, because we have the incoming tweet with all its data, and we will publish an event of type tweet received, and that has the tag included, which is the #Microsoft and the full object for the tweet. You could create your own object, but in this case, for demo purposes, I've left it at just the original tweet object that has all the information. Now, if you look at how this is done, the Dapper client is being given to us in this configure method, because all the things that are listed here are also injected by the dependency injection framework, and we've used this add Dapper client that we saw before, registering the Dapper client type, so we can be injected here. So we get the Dapper client, we publish it out to our message bus component, which we should be able to find here in this pub sub. So here we see that there's a component called message bus of type Azure Service Bus, but we can change this around. And simply changing this around to, for example, Nets or Redis, we could just as easily switch to a different implementation for the message bus. That's why this name is not referring to Azure Service Bus, because if you would be changing it, it would also mean that you need to change this value. So this should not expose, I think, the particular choice of your message bus. It's just that you're using this component, message bus. And we will put this in, and the wrapping into a cloud events envelope will be done by the Dapper sidecar. So this is enough for us to get everything injected or pushed out onto the service bus. Now, on the other side, we have the leaderboard web API. This is our most mentioned component, and it will receive everything. And let's have a look at what is happening there. So in our program CS, we have the use startup again with a little bit of actor bootstrapping. But in our startup, we will do some things such as adding Dapper to our controller, so we can have all these nice methods available to us in the controllers. And we have the use cloud events, so we can do the unwrapping of incoming cloud event messages and extracting the data from it. And we have this map subscribe handler that exposes the endpoints. Now, because of the conventions used, the component for PubSub is listed here as well. So we have, again, this message bus, and it's In this case, it's referring to the same thing because we're on the receiving end. And this allows you to configure all the connection details for the service bus. And then inside of our controller method, we go to the most mentioned controller. And down here, we have this method here that says handle mentions that will pick up the messages that were published before. So you have the message bus with mentions, which corresponds to the mentions that we put out here. So that's the subscriber part. This is the publisher part. This is the subscriber part. And we get this tweet received message, and we also inject the Dapper client here. Now, first thing that we'll look at is that there's a bit of logging that it says Twitter message from, and it will give us the user that is mentioned and its screen name. And then it will start storing the state into the state store. The state store is listed here as well. And you can see that this is, for testing purposes, we're using a local hosted Redis, a state store. This should be enough to get everything running. Remember how we started the Twitter monitor? It was from the command line with Dapper run, and it would get everything started. But now we're using these parts here. We're using the Azure Service Bus, and we need the sidecars, and we want to have everything listed together. Now, the way that you can do that is with Docker Compose. And in Docker Compose, we'll be running our two services. So we have the Leaderboard Web API, and we have the Twitter monitor. The Leaderboard Web API is referring to a Docker file that will build a Docker image from our Web API implementation. It exposes the HTTPS and or the HTTP and the gRPC endpoint, and it will be deeply connected through a network to the Leaderboard Dapper. Now, the special thing that we'll be doing is that we will also start a Dapper sidecar. And I'm using an image provided by the people from the Dapper team, and it's using the almost released 1.0 version. We're currently at RC1. It's being configured, the sidecar, to have a app ID. It has a port exposed. It has the components folder listed, and it specifies where the gRPC port is. And this is one off from the default port, so we don't get any collisions from running it locally without Docker images versus inside of a Docker composition. Now, this one is very important. It says that this sidecar is connected through network mode to the service called Leaderboard Web API. Meaning that if they are referring to localhost, they are actually finding each other instead of not finding each other and needing specific names. We have the other things also already available, like the placement service, which we would need. We might be looking at the Zipkin a little bit later for the tracing. We'll skip Prometheus and Grafana. We'll have the Redis running as well. And here we have the Twitter monitor, which is the first part of our application. Again, with a Docker file, using a different gRPC port, and specifying a Dapper sidecar again with the particular port that we specified earlier, and also deeply connected, in this case, to the service called Twitter monitor. So they're all also connected together. And all of these are finding each other in this big Leaderboard Dapper network that is the overall network. But the sidecar and the individual services are more deeply connected to each other. And with that as the startup project, we can start this entire composition, and we will compile all of the .NET Core code. It will build Docker images from it, and the composition will now be creating all of these various running container instances, and the magic will happen. So let's clear out a bit of the logging and see what is happening here. So the Twitter monitor should be picking up Twitter messages if they arrive. And so there's one coming. And the Leaderboard Web API will be handling those. So we just saw a moment ago, we saw this mention of Slonsog. And here we have Twitter message from it being given to us in our most mentioned handler for each of the things that are coming in. And we should be able to see those messages in our web API, which we'll cover in a bit. But here you can see that whenever there's an incoming message, they are already being pushed out to the UI. Now, that means that we're up and running and we're pushing things to our Azure Service Bus. Let's have a quick look if we can see that pass by. So if we go to the Twitter leaderboard, we can see that we are already receiving messages at this point in time. So that's good. Let's go back and look at a few more slides. Next thing that we'll cover is actors. And there's a lot to be said about actors, but it's a programming model that allows you to deal with a representation of something that has state called an actor. It's something that you can talk to and where you don't have to worry about concurrent access to the state that is deeply connected to this particular actor. In our case, we would like to use an actor for representing one leaderboard for a hashtag. So there's one actor for hashtag Microsoft, and we might have other actors for hashtag Dapper, or maybe even mentions for a filtered stream that is at Azure AzConf, for example. And then we have an actor storing the state of the top mentions that are available. Now, the beauty is that the actor model takes care of all the complexity of making sure that the calls that are made are handled in a sequential, serial fashion. Actors will remain around, they will live somewhere, and if you have a cluster with multiple nodes, the placement service will know where each actor with a particular ID is living. And they will be garbage collected if they're not used often enough. You can have reminders and timers to keep them alive or to start them up again. But this is not your concern because it's taken care of by the programming model. Now, because the actors store state and they have their own state, you need to specify a state store that the actor programming model will use. And this is indicated in one of the state store components that has this actor state store true mentioned. There can be only one, because otherwise there would be a collision and the actor runtime wouldn't know which state store to pick. So you can have only one that says state store true. And then calling the actor is, again, same thing all over again. It's interacting with the sidecar with the use of the well-known endpoints. So the endpoints for the sidecar that mention the particular actor type, its ID, and the method that you want to call. But there will be convenience methods if we're programming in .NET Core. Let's have a look at that. So we'll expand our project with providing an API, and we'll use the actor programming model to actually create the leaderboard data. Okay. If we look here, there's a little bit of a mention inside of program CS where we say, okay, we want to use actors and we want to register a particular actor type, leaderboard actor. And this is an actor that stores the state for one leaderboard. So the data that we're going to show in our leaderboards that we already saw right here. So this data is stored inside of the actor and we want to interact with it. Create an update and then notify the UI. This actor is implemented here. The actor is based off of a iActor interface, and inside of the interface you specify how you can interact with the actor. So we can submit a score by providing a new score for the leaderboard, and we can ask, give me a ranking for the top 5, the top 10, or whatever we provide as an integer. Then the leaderboard actor is an implementation of this iLeaderboard actor interface using the base type of actor to give us all of the plumbing that we need. We need a special constructor type, and then we implement the interface like getRanking. The way that we get the data is that an actor from the base type actor will give us this property called state manager. And we can get the state of a particular type by mentioning the name of the state that we're storing. And in this case, it's an ordered list. And if the list is available, we'll take the top of the ranking that we want to have. And if it's still empty, it means that it's the first time that we're asking for ranking even before there's any state stored. We will just return an empty list. And similarly, the submit score gets the score of the current ordered list. If there's none, it will again create an empty list or use the current value that is already in the state store. And then it will remove any entries for the score that is being submitted. So there's an ID, unique ID, the name, the screen name, and the score. And then we'll add that as an entry to the ordered list and write out the top that we want to store. In this case, the max entries is 10. So there's never more than 10 entries stored inside of this actor. And that will be stored automatically again. So that's what's happening behind the covers when we interact with the actor. And we're doing that in the most mentioned controller. So we were at this point where we save the state. Then we will create an actor from an ID that matches the hashtag Microsoft. So the actor ID will be Microsoft. We will create a proxy specifying that the shape of the actor is our leaderboard actor. And we will extract all of the mentions. And for each of the mentions, we will store it in the count that we have in the state store. So this is normal state store. First, we will get the current count. And if it's not there, we will set it to 0. We will increase for each of the mentions that we saw that mention again, save it again. And then here we submit the score to our proxy for the actor. And it has the ID, the name, the screen name, and the count that we just discovered. So we're keeping track of how often we saw each of the entries in our state store. And we're letting the actor figure out what the top ranking is across all of these. So we don't have to perform queries each and every time. And we can use some logic to make sure that we have a particular list in there. Now, finally, we'll get the ranking of the top 10, and we'll do something with SignalR, which we'll get to in a moment. Also, we have a leaderboard controller, and the leaderboard controller is able to give the most mentioned, and it will just use the same thing. It will get the ID of the actor, create a proxy, and then finally call our getRanking for the top that we get from the query string. And if it's not specified, it will just choose 10. So this is enough to give us an API that is available at most mentioned. Let's have a look there. So if we go to our this here, we can say most mentioned, Microsoft, and it should give us the entries that are available now in the top 10 from the actor state store. All right, so with that, well, let's move into the final part of our application. If we want to do something else, and in this case, we want to signal the front end that something has changed, so we don't have to query the API endpoint for the getRanking all of the time, we can use SignalR to push out notifications to the front end. Output binding is very similar to input binding, but the main difference is that when you're using the Dapper client, you will be the one initiating the call. So if we look back, there's this invoke binding where you will name the component that you want to use, the particular command that you want to give, and in case of SignalR, it's always create. and you will send out some data in a specific format. This is everything you need to interact with SignalR. So no detailed knowledge about this component is necessary, just as long as you know how to create an object of the particular data that you want to send. Now, so the next part in our application is that we will be, I'll show you this front end built by my colleague, Thijs Limmen. It's a Vue.js front end that calls into this endpoint and is also subscribing to a SignalR hub that is hosted in Azure SignalR. So we'll make those two connections and briefly look at what is needed to do that. Going back here, the SignalR invocation data is an object that will be serialized. In this case, it's using this target called leaderboard updated, and it will send an empty argument list because it's only a signal something has changed and a new call to the API will be made by the front end. You could choose to send the delta, the changes that were actually made, but in this case, to keep it simple, it's just a notification, something has changed, and it will call the API again. And to send out this, to the SignalR hub, we do this invoke binding, we specify the name of the component, and the component, as you know by now, should be listed here somewhere. So we have this output binding where it says, this is the type of components, a binding to Azure SignalR, and these are the connection details with a long access key to allow you to access this particular endpoint. Now with that, the only thing that we need to look at is the front end, which is a single HTML file, and somewhere near the bottom, we can see that there's whenever there's a call to get leaderboard, we will use the API endpoint. And there's also mention of this bound message that says whenever there's the leaderboard updated, remember, that's the action that we're sending out, it will do the leaderboard updated callback method here in our JavaScript. And the leaderboard updated, once that is called, it will get the leaderboard and do all of this rebinding. So that's about what is needed, and there's nothing much more to it. And the net result will be that we have this leaderboard here that will change whenever there's incoming messages, because there's an incoming Twitter message, and once it arrives, this message is pushed to the front end, and we will make a new API call. Now, the final part that I would like to show you is that it's very easy to get detailed tracing information from your application. You will define a component. Zipkin is one of the ones available. There's also the native one where you can integrate with the Azure tracing that is provided, or you can have testing to string-based trace information. In this case, we're running a Zipkin container, and this container is a self-hosted Zipkin implementation that is running at this local host address. And in our configuration, we can tweak the sampling rate a little bit, but this is just about what is needed to get that up and running. So finally, last part of our application is that we want to see how we can view messages coming in from one side, flowing to the other, and all the things that it's hitting in between. And on both sides, we're using Zipkin, and that is, fairly trivial to get going. As a quick reminder, in our the definition here, we have a Zipkin, but we're exposing it at port 9412 instead of the default port, so we don't get any collisions. And well, that's about it. We have the little bit of a definition for the information here. We have our config that has the sampling rate of 1%, and that should be enough to give us a lot of rich information on localhost 9412. Now, if we run this query, we can be specific. We can, for example, say, take this service name, leaderboard web API, run the query, and see whatever is happening. So let's just pick one of these things. This is the component Twitter monitor where things start. You see that there's a couple of calls inside of it. And if we drill down into the details, you can see that then when there's a Twitter monitor binding happening, we're publishing the event, and finally, after it travels across the Azure Service Bus, it ends up at the other end in the leaderboard web API, where we're doing these calls to the actor and to invoke the binding to SignalR. So we have this nice flow across all of it, from the Twitter monitor all the way up to the SignalR to the front end. We can look at the dependencies, see what is happening there. And you can even see, in this case, it's only 2 moving parts, but you can see the messages flowing from one side to the other. Now, this is not real time, but it gives an indication of where things are going. And in a more complex scenario, we will have more dots and more flows of information between the two of them. Now, with that, I hope that you saw that it's fairly easy to build a distributed application using Dapr in combination with .NET Core. Dapr takes care of all the heavy lifting, so it takes away a lot of the time that you would need to spend to learn about Twitter, about Azure Service Bus, SignalR. We didn't need to do that. We only needed to know how to interact with the Dapr sidecar. The good thing about Dapr is that it's cloud provider agnostic, meaning that you can switch from Azure to somewhere else, to Google Cloud, for example, or AWS, pick their PubSub implementation without having to change your code, just changing the component definition files, that is YAML. Dapr is evolving. It's nearing its 1.0 release. If you go to the website for Dapr, you will find that we are currently at release candidate 1 and release candidate 2 being prepared for an oncoming 1.0 release. So we're almost a year in and going to a production scenario with it. I've listed some of the resources here. You can reach out to the Dapr team with the Twitter handle DapperDev, or you can join the bi-weekly community calls and get involved in the Gitter rooms, where you can discuss the Dapr, the samples, the community contributions, and more. If you have any questions for me, feel free to reach out. I'm available at my Twitter handle at AlexThissen, or you can send me a mail message at my email address listed here. Thank you very much for attending this talk, and hope to see you sometime in real life on a next Azure Community Conference. Enjoy the rest of the conference and have a very nice day. Thank you, and bye-bye.